Well, hello there everyone. You've tuned in uxwbill. Some time ago, someone made a comment on one of my videos telling me that I needed to repair a mini fridge. I don't know if that's perhaps a not so thinly veiled reference to College 153's long ago defunct mini fridge, or if someone was legitimately interested in seeing a mini refrigerator repair, but here we go. You just never know what's going to happen around here. This is not College 153's long since forgotten mini fridge, although I think it's still around here somewhere. This is actually something that I paid way too much money for at the Goodwill. Seemed like a good idea at the time, as so many things do. I think they call that buyer's remorse. I had it kicking around here for a while, used it for various and sundry things, and then Bizarre Furhead asked me if he could take it to college, and I said sure, why not? You know, you can have that in your dorm room. I just ask that you take care of it and not break it. Now, I certainly won't accuse Furhead of breaking it, because he definitely didn't do so. He took reasonably good care of it. I mean, there's a little more rust up there, and it's a little more banged up than it was when it left here, but I think he tried. I'll give him the benefit of the doubt. But he mentioned that the fans inside it were getting louder and louder. They were starting to sound like lawnmowers, and then one dark day he told me that it just flat out quit working. So I'm out here cleaning up the garage right now, and I thought I'd just take a look at this thing and see what was going on. Now, some of you in the audience have probably noticed that this particular refrigerator is a little bit different from what you usually see, in that there's no visible compressor on it. Now, you might be thinking that it's shrouded behind this rear panel, but that wouldn't really explain these two fans. This is not actually a refrigerant-based system. This is, as the nameplate indicates, a thermoelectric refrigerator. It uses thermoelectric cooling, also known as a Peltier device, which I hope I'm pronouncing correctly. I never know if I am, so I usually just call them TECs, or thermoelectric coolers. I was cleaning up the garage, and I ran across this thing, so I just decided to see what might be going on with it. It's pretty late at night. I'm not really sure how far I want to get into this. But the first thing that we can do to try and test it out, although being the chicken that I am, I'll probably actually put the back cover back into place for this. I jumped the gun a little bit here. Just in case something should happen to blow up. Let's see, we'll just put that screw in a little bit here. This right here is Academy Award winning, that's probably a trademark, camera work. Now, ordinarily, if you were going to plug in an electronic device having unknown amounts of functionality and unknown problems, especially a really old device, you would be rightly called a fool for doing so. But I know a bit of the history behind this unit. Furhead said that it just stopped working, and if it was going to blow up, it would have had ample opportunity to do so at the time. So we'll go over here and we'll plug it into this outlet strip, and we'll just see what happens. Hear what I hear? A kind of faint whining noise. That would tend to suggest that there is an overload or some other kind of fault being experienced by this thing's built-in power supply, which, being as the demand for current here is relatively high, thermoelectric coolers are not enormously energy efficient devices. I think a simple mechanical refrigeration compressor would actually have them beat. This thing has pretty hefty power demands. Now, to look at this power supply board, I don't really see anything distressed. We know that since it made a noise that the primary side circuitry must be in close to working order. It could still have a problem, but whatever's wrong wasn't serious enough to blow the fuse. Now, when a power supply operates abnormally, like this one presently is, it would be a very prudent idea to make sure that all energy storage components, like these two capacitors right here, which could certainly pack a heck of a wallop, since they're sitting just after the rectified AC power coming into this thing, make sure that they're discharged. I wouldn't bet that there aren't bad capacitors on this thing, because as you can see, they are all from internationally unrenowned brand Aishi. As I said before, did someone just sneeze in here? These two that sit just past the bridge rectifier, they're equally unrenowned. They come from HY, and I wouldn't be surprised if anybody did research on those, which I can't do right now, if they didn't find those were potentially well known as bad capacitors. So let's take a look at these fans, just see what they do, see if they turn, because overheating certainly could have killed this thing. Of course, the fans turning, it doesn't necessarily indicate that they're actually any good, but it shows willing, and even if the bearings are bad, as Furhead seemed to insinuate, they're not so bad that I would imagine the fan motors to be this thing's primary cause of failure. I'm guessing that something is almost certainly wrong on the power supply board, and since it's fairly late at night, that may just be where I want to leave it for right now. Well, even though I said previously that I wasn't really sure how deep I wanted to get into this particular project at this late hour of the evening, actually it's early hour of the morning now. If you're in for a penny, you're in for a pound, and my variable regulated power supply is never very far away, nor is a multimeter, so we might as well just go ahead and have a look at this. Now, rather interestingly, it seems like the manufacturer suspected that the fans would probably fail in this unit, maybe even while it was still under warranty. So they actually put detachable plugs on those, which is a nice touch. I mean, you could get something like that off the shelf. But the actual power going to the thermoelectric coolers is hardwired to the board, although again there are outlines on the board. Out plus, you can see it right there, and ground. It looks like they thought about putting connectors in place there, but I guess they decided that if something like that was wrong, they'd probably just dump this unit and hand the owner another one. What we're going to do, since I'm not too deeply concerned about power supply board, since I think it probably is the problem in this thing, we're going to engage in a very high-tech methodology here of disconnecting the wiring. If it turns out that the power supply board is innocent, something that I might test later on, something that will certainly be proven out by trying to power these up, then I can just use some sort of splice connector, or I can even solder those back together and then heat shrink them. But the next thing to do will be to strip these wires, and somewhere around here, just prior to this, I was messing around with computer equipment, but somewhere around here I actually do have a wire stripper, if I can get it without triggering a crap avalanche. I'd really rather that this set of drill bits not end up on the floor. I mean, anytime something falls on the floor, it makes me wildly angry. I know there are some of you in the viewing audience who probably wouldn't believe that, but I do have a rather bad temper. It takes a long time to get there, but boy, when it does, you better look out. So I'm going to go ahead and strip off the ends of these wires so I can work with them, and then we'll make some tests and do some ciphering and see what we're dealing with here. Alright, so now I've gone ahead and derouted all the wiring. It was held in place with a couple of zip ties, and well, I realize that's good practice in mass manufactured devices because the shipping people try so valiantly to have their way with things, and only fairly drastic measures would ensure survival of these items as they make their way across from the slow boat, on the slow boat from China. But I've gone ahead and I've stripped off these wires here, I've stripped off these wires down here, and for right now I'm not even going to worry about the fans. These things would overheat pretty quickly without the assistance of the fans to cool them, but for a short test it should be fine. Now, one thing I wanted to touch on earlier that I forgot about, given the completely unscripted and ad hoc nature of these videos, is an explanation for why the power supply board is doing what it was doing. I don't know exactly what the mechanism of the fault here is because I haven't diagnosed that yet. But if you were wondering why is it that there is suddenly a noise produced within the range of our hearing, well, it has to do with the fact that the regulation inside the power supply, which ordinarily operates at a very high frequency, well outside of the range of human hearing, although some dogs and cats and other animals might well be able to hear it. If there's an overload or a very heavy load on a power supply's output, the frequency of the regulation, as determined by its controller circuitry, might actually drop into the range of our hearing. You can hear it as like a hiss or a whine. Some power supplies do that even when they're working normally. If you ask my opinion, that means it's a very cheaply designed power supply. But hey, if they can sell it, they certainly will. And of the things on here that can make noise, the transformer cores certainly can. These two guys right here, you could certainly hear them making noise. This large inductor right here, this coil, you could also hear it making noise as well. So that's an explanation for anyone who is wondering about that. Now, I could just go ahead and take some clip leads and sock power to these and see if they come up working all right, but you know me, I'm a little more cautious than that. So we're going to whip out the multimeter here. I actually have, I don't drop it right on the floor, because that's the problem with a lightweight digital multimeter. You need a Simpson 260 or something that's really got some staying power that'll sit there while you whip these things around in the name of bringing them into the camera's field of view. The test leads that are on this are not the Mastech originals. These are actually something that you can get at Sears. It's a well, I knew that was going to buy the farm sooner or later, and sure enough it did. Wow, distraction. This is a multi-purpose test lead set that you can get at Sears, if there are actually any Sears stores left in your part of the world, sold under the Craftsman name, as you might imagine. These things are a bargain at like $25 or thereabouts, and if you have a Sears store near you that happens to be closing, you might even be able to find them for less than that. But the one thing I don't seem to have here that I thought was part of this kit was a set of alligator clip leads. I'm practically certain there was a set included with this, and they're probably sunning themselves on the floor in here somewhere, so that won't really work. It would be very tedious to try and do all this on camera. I just don't have enough hands, but I just caught sight of something that will really help here. I've got a set of cheapy test leads, if they didn't fall on the floor, and it doesn't seem that they did. These things are junk. They cost like $1 on eBay, and they're not worth even that much. But for a simple low current test like this, they'll work just fine. They've got alligator clips on the other end. Don't use these for high current applications. Don't do what uxwbill did and have them in series, utilizing a multimeter as an ammeter, and then finding out that you were sinking enough current into your battery array that you caused these alligator clip ends to desolder themselves. So I'm getting ready to hook up here. We'll put the multimeter where you can see it. It's indicating infinite resistance right now because I haven't completed the circuit. And we're going to put this across the first thermoelectric cooler. And I don't know what kind of resistance is normal for these things. So really the only test I can make here is a rough approximation followed by a process of elimination. This first cooler ohms out at roughly 4 ohms. So it's not a dead short, but that is pretty low resistance. Now we could use Ohm's law to solve for how much current would be drawn. But at this time of night, and without a calculator handy to verify my numbers, I'm not even going to try to do that, because math and I do not get along particularly well. I do alright if I'm just making random off-the-cuff figures with nice round numbers, but if I get to thinking about something too much, and then I'm out in left field and doesn't really become obvious until I've embarrassed myself. So here's the second thermoelectric cooler, and let's just see what we get here. And this one measures a little bit higher in terms of resistance. 4.3, okay, it floats around a little bit. Now it's at 4.5 ohms resistance, but that does tell us that these are not likely to be hard shorted. They could be faulty. They could have a problem that would result in their overheating or drawing far too much current from the power supply board in this thing. But at the very least, okay, there's a blue LED attached to my other clip lead there. It shouldn't result in an instant meltdown, but what we're going to do here, and I'm not going to power up the fans. I should probably try and see if I can set the camera where you can see me doing this. So I'll be right back after I've done that. Alright, so instead of going inside and doing the right thing and getting some form of a tripod or another, I've decided to just balance the camcorder precariously on a foldable ladder, a car battery charger, a multimeter case, at least one air conditioning book. So when it goes dive bombing off there, you can all say in the comments that you told me so. Remember folks, uxwbill is a bad example operating on a closed course. So here's what we're going to do. I'm going to turn on my variable regulated power supply. If you can see me in frame and you can see how I'm sweating, you'll know that it's exceptionally hot out here. We'll just go ahead. I might even put these on the proper color wires. Although in the case of a thermoelectric cooler, it really doesn't make that big of a difference, because if you reverse the polarity to one of them, the cold and hot ends simply change places with one another, which would turn this from a mild-mannered refrigerator into a hot box that would be perfect for torture testing all sorts of electronics. Now, we're probably going to need a fair amount of current delivery here because, as I mentioned previously, these things are power hungry, and I don't know if this little 5 amp regulated power supply will have enough moxie to pull this off. I may find out that it doesn't. We're drawing about 40 milliamps there, and we'll just start cranking up the voltage. Not sure that's the best sign in the world. This thing just hit its current limit at 5 volts, so damn the torpedoes, full steam ahead. There may be something wrong here because this thing is, it's really chowing down the juice. And I wouldn't swear that this thing is really designed to output its full rated current of 5 amps at all times. But what I'm looking for here, I was going to power up the fans, but I didn't want to cut off the connector on their body, on their wiring harness. And I couldn't find any paper clips to jam in there. I didn't feel like looking for them at this hour. Let's just see if we're starting to get hot here. And there is warmth in there. I don't have a Type K thermocouple out here to prove it to you. But I'd say this thermoelectric cooler is probably working. I could spin that fan and try to get some air moving across it, though I probably can't spin it anything like fast enough. Yeah, there's some heat coming out of there. But you can really see how that thing's sucking down the juice. I think this thing's upper limit. Well, there's a calculator over here somewhere. We'll just figure it, assuming it works. This is my old trusty Rockwell. We're at 12.3. Come on, you silly thing. Yeah, this thing's being a little flaky. Not really working right. Got some debounce problems. I think this thing probably needs some attention, but luckily I have another one here, equally vintage. Oh, Calfax 890p. So let's see what we're doing here. We're putting out 12.3 volts and we're drawing 3.94 amps. That gives us about 48 watts, and I think the upper bound on this thing is somewhere around the 60 watt mark. So yeah, that thermoelectric cooler is really sucking down the juice, and boy is it hot. Okay, so it's probably fine. We'll turn the voltage down again just as a precautionary measure, and we'll try the second one. You know what, we'll wire it up in reverse just so you can see the effect. I might even go inside and get one of my Type K thermocouples and hook it up. That's my undying dedication to you folks. Some of you have been clamoring to see diagnostic videos, and this is about as close as I'll probably ever come to it. Because most of the time when I'm doing electronic diagnosis, I like to think about what I'm doing. I don't like to be rushed. I don't like to be hurried. But I've got the polarity hooked up on this one in reverse. And where this one got hot, this one on the outside should get cold. And it's definitely cooling down. So I'll just let that sit there for a moment or two. Let it cool down a little bit more. And then I'll pause the camcorder, which hasn't fallen off of that precarious stack just yet. And I'll get a thermometer, thermocouple of some kind out here, and just demonstrate the effect to you. So evidently whatever problem we're having here is confined to the power supply board, and I'm going to take a guess that every rotten capacitor on here, especially the big guys, they probably need to be replaced. Because I've tested the output for shorts. The output doesn't seem to be shorted, although that really only tells you so much. I've also gone around in between takes here hit some of the power devices on here, and they're not shorted either, so I'm thinking it's got to be another casualty of rotten capacitors. So yeah, that thing's cooling down nicely, which means the one on the other side, inside the refrigerator compartment, is actually heating up. So in order to make my life a little easier for the sake of this next demonstration, I decided to take the door off of this refrigerator. In theory, at least, that is doable because there's a blank plate in the case on the other side where you could install the hinges if you wanted to reverse the swing of the door. So let's see here. Probably just comes off with a little bit of... maybe not. Well, when patience and careful investigation aren't the cure, violence is. Come on, you silly thing. 10 points! Alright, now we just got a couple of bolts. They've got screw heads in them, but I happen to have a driver here. So we'll just buzz those right out. I would not recommend this as an approach for putting these back in, because very often they go into something soft that is not at all significantly structural. You will strip them out and then you will be sorry. You will have to have the door on your refrigerator swing out the other way. For those of you who are wondering where the Dell flat panel went that was sitting there, I decided to move it before something deleterious happened to it. Ha ha ha. But now that I have some room in which to work, I see that Furhead is an incredible Sibonian as usual. But I have my dual input thermometer right here. And I'm going to go ahead and set that up. And rather than taking all of you along for the ride, because I really think I'm courting disaster the way that camcorder is balanced over there, I'll pause the video for just a moment while I get everything set up. Now I've got my test rig all set up. We have one temperature probe back here on this heat sink, and the other one is inside here. I took the little fan out of the way. It wasn't too hard to do it, just 4 screws. Interestingly, the heat sink on this side is much smaller, even though they're both fan cooled. As you can see, the first input, which is on the heat sink that would normally be cooled, is actually still quite hot. It's holding on to a fair bit of its heat. And if you're wondering what that is in degrees, that's Kelvin. That's degrees Celsius for everyone that watches these videos outside of the United States. Let's go ahead and hook things back up here. I want you to listen very carefully to the speed of the fan inside this power supply when I make the connection. You can tell that it's under a considerable amount of strain. Hear it drop in speed there. But now what we should have happening, this heatsink should be getting cool, and this one inside the unit should be getting hot. I'd say the safe junction temperature is probably around 150 degrees Celsius. We're going to terminate the experiment before we get anything like close to that, because these things are not meant to run without their ancillary cooling fans helping them out. But the figure that we're interested in here, we'll just see what the cool side's doing. Okay, the cool side just fell out. That's productive. Get back in there. Cool side's not making as nice of a contact, but we'll just switch here. Not that much cooler. Of course, like I said, it's hotter than Hades in this garage. And then we'll get our delta T figure. Delta is just a fancy way of saying difference in this case. Seems there's about 50 degrees difference between the inside and out, and it's rising, which suggests that while we're heating up here, we're probably also cooling down here. Yeah, we're getting up to 130, 140 degrees almost on the inside, and we're coming down to about 80 degrees on the outside. And this thing's not 100% accurate, but it's close enough to illustrate the point. And of course the exhaust air from the power supply is plenty warm too. In fact, we'll go ahead and unplug this, because it's really not a good idea to run these things for too long without cooling. And we'll just put this up here. That didn't stay. As you can see, the power supply is certainly being pushed as well. The temperature's just shooting right up there. So I've diagnosed this thing, traced it down to a bad power supply board, and given that these things are both of cheap and pretty much universally available from all manner of discount houses, electronic component suppliers, and of course the friendly, lovely Chinese sellers on eBay, who might be closely related to the company that manufactured this particular unit, I'm probably not going to invest much more than a recap in this, and if a recap doesn't bring it around, then I'll just try to find something compatible. Going to have to be pretty hefty though. Looks like it's on the north side of, I would say, for comfortable operation. And this thing's probably a little light for my liking, especially since it's primarily passively cooled and it's taken the heat off of this heatsink in particular. I think anything that would have a prayer running this comfortably would have a 12 amp maximum output figure. So thank you as always for watching, and certainly do feel free to leave a constructive comment if you happen to have one. I'm always interested in hearing people's views.